Hey, good evening, everyone. Thank you for joining us for this new live. There was a bit of a break, but this time that's it. Lives are back. And actually, there is like the choice between so many topics because we had a lot of announcements at WWDC. But one of the biggest one was, well, not only async await, but everything that comes after async await. So structure concurrency, actors, basically so many things. And I'm super happy this evening to have Donny Wals with me. Welcome, Donny.
Hello.
And so, as you've seen from the title, we are going to talk about structure concurrency and more specifically about actors. And we're going to see what they are, how do they fit in the picture, and basically why they are going to become a big part of our code in the near future when we start to adopt Swift new concurrency model.
Yeah.
So, well, maybe before we begin, let's try and speak a little bit about the kind of problem that actors solve. Because when we use structured concurrency, basically, we make our code much more concurrent, or at least it becomes easier to make our code concurrent. But with concurrency, there comes an entire, we could say, class of bugs and issues. So, and the most known one is data races. So maybe we can say a few things about data races. What do you think, Denis?
Yeah, sure. Where do we start? A lot of us have probably written code that we might not even have thought about, but it's probably plagued by data races, but we don't notice it because our code typically will run sort of in a serial manner, or it will not necessarily be code that is going to be used from many threads. Now, when I was at Disney, I worked on an SDK, and then one big thing that we had to keep in mind is that we didn't know how people would use our code, right? Like, you're just going to build the SDK package up, send it over to some person. So that person could be writing very highly concurrent code, and anything that they would call on the SDK could be called concurrently. So thinking about how something acts in a situation like that is something that I do a lot. Now, a data race, basically, before I go into all of the problems surrounding data races, let's uh, maybe explain what a data race is. So, a data race is whenever you access a mutable piece of state on an object from multiple threads at once, and at least one of them is a write action. But if everybody is only reading that piece of state, there's no problem because I mean they're all competing to read it as soon as they
Yeah.
can. But they'll read. That's fine. But if one of these things is a write, then things get weird because you might think, okay, this thing is going to run and is going to do a bunch of stuff, and I will have a write operation and everything's going to be fine. If two things are a write operation, that's when things get messy. I don't know if you have experienced this a lot, Vincent, but I have.
Yeah, and what's so weird about it is the unpredictability of it because you never know first when the bug will occur, and then when it occurs differently because basically, well, the thread were executed in a different order, so it makes it like very hard to diagnose and then understand and solve.
Yeah. So one example that comes to mind that I'll just quickly type up in a little playground here is, remember when we all sort of saw Swift's atomic property wrapper, like, or we all made our atomic property wrapper, like, oh, we can apply this to a thing, and you would write code a little bit like this: atomic var my thing, and it would be some dictionary of maybe a string and more strings. Now, this thing had a problem that's related to the semantics of a dictionary. And I'm not going to write an atomic property wrapper right now, but what I will do is I'll write something that works in a similar way. So what I'm going to say is I'll have a class here, and that class is going to be a lookup thing. We're going to look up stuff. And we just have a dictionary here, and we're going to call that our stuff. And that stuff will be a dictionary of string and more string. Right, nothing really special here. And we're going to have a function here, and that function is going to be set value, which will be a string for key, which will also be a string. This is, of course, a very silly example that you wouldn't really use probably, but it helps me explain this really well. So I'm going to pretend that this makes a lot of sense. Now, we'll also have a get value because we're not going to read the dictionary directly. So I'm going to say get value for and then the key, and that'll be a string. And
And
we'll return an
actually,
optional string.
should we like maybe also turn the dictionary private,
That
or
was
is
going to
it?
be my next step. Yeah,
Oh,
for sure. Good suggestion. Because if we don't want anybody to mess with it from the outside, that's what we want to do. So this sort of contraption, I don't know about you, Vincent, but I have written this before. This is very realistic apart from all the naming. Would you
yeah,
agree?
yeah,
Okay,
and
cool.
the pattern of like you put some data structure in a type and then you aggregate them through some like methods to read and write. That's something that happens a lot.
Yeah, exactly. And so I could say, well, I'll have this constant, and it's going to be a lookup, and it's going to be a lookup thing. And right, I can say lookup dot set value hello for the key will be greeting. Then if I say lookup get value for greeting, this should get me a value. Let's print it too. This should get me some output.
So it's going to set some value and then
Yeah.
retrieve. Yeah,
And so this playground is going to hurry up. Then I will.
you never know with a
Trust.
playground.
Playgrounds are always so unreliable, sadly.
Yeah,
All right, let's quickly do something different. I'll just make in my Swift UI app here. I'll make a button. Run the code, and that will just I'll take this stuff. I'll throw it in there. And I'll take this stuff. Now, don't do this in your own apps because this is not good code, but this is going to work faster than the playground. So we should see here optional
yeah.
hello for every time I click it. Makes sense. It's a little bit weird maybe, but it works. So to make this a little bit nicer, I'm going to say class sample runner. I just want to have some context to run this in because I'm going to do some funky stuff. I have to look up here on the sample runner. And then in the run function, this is where I'm going to do the funky thing. I'll make that constant. Just going to be lookup equals lookup thing. And this will just call lookup, or no, it's going to be a runner, sample runner, runner dot run. Okay. Just faking playgrounds as we go. Why not? Just to show you that everything is still fine.
Yeah.
If I run this, the output is going to be the same. Okay. So now what we could do is, let's say we want to insert like 100, 20. Let's do 20 values into this lookup thing. So I'm going to say
Yeah.
for index in 0 to 20, lookup dot set value, and then index for key, and then use the index again.
Yeah.
Right, and then we'll also just print that value for that specific key. And we'll see that this is fine. There's one more thing that I want to add to my lookup thing. Wait, what did I do? Oh, I didn't print anything. There's one more thing that I want to add to this lookup thing, and that's the ability to get the whole dictionary, right? So
Okay.
I'm going to add a function here. It's going to be func get all, and that will just return string, and it's just going to say return stuff.
Okay.
This is going to show us what's in the dictionary, because that's valuable to know, because if we know what's in there, we'll know what went wrong later. Okay, so there we go. So run the code. You can see
Okay.
now that my dictionary has all these values in it.
Yeah.
Okay, so far so good. But what happens if this run function now stops being serial, because it's serial right now, right? Every for loop index or every for loop iteration is going to run one at a time. So we'll not have anybody competing for this inner stuff dictionary. So what we could do to sort of make this run in parallel is say dispatch queue dot global dot concurrent. What is it? Async perform concurrent. Oh, it's dispatch queue dot concurrent perform. That's it. It's not on an instance. So we're going to perform something 20 times. So this is just going to be more like a parallel for loop, right?
Yeah.
And we'll give this a closure. And it's going to be very similar to what we had before.
And it's always very funny. I find it to see that we have this concurrent for each in Swift for a long time, but the name is like so not what you would expect, that it's very hard to discover it. Like concurrent perform, I discovered it
Yes.
very lately in Swift.
Yeah, it's not very obvious to find this one. But so this will do this line of code 20 times concurrently with an index. So it's just going to be a for loop where we don't wait for every iteration to finish. So let's see what happens when we print get all. There we go. That's a crash. Right? It's not even going to give us anything. It's just going to immediately be like, nope, we're not going to do this. And it's telling us bad access. And the reason it's doing that is because we are concurrently modifying or trying to modify the stuff dictionary. Now, I want to try and run this one more time, but every time after I set a value, I'm going to do get all. So we're just going to see what happens when I do that. And again, it immediately crashes. If we do this a couple times, there is a chance that we might see some output once or twice, but usually you'll see that your app crashes, and it's just going to keep doing that. And the reason is that we are both reading and writing stuff here. We're reading it because we are doing the get all lookup. We are writing to this one dictionary from multiple concurrent operations. So we're trying to set index 1, index 2, index 3, for example, at the exact same time. And the dictionary is just like, I'm not having that. I don't want anything to do with that idea. Get out of here. We're going to crash. Right? So that's a data race on stuff. Now, there are cases like in the atomic property wrapper where I've managed to get this to work. However, what you'll see is that maybe you get one, maybe you get two values in your dictionary, but you're never going to get all 20. And that's because this is a data race. This is funky territory. This is not supposed to work.
And
So what we can do about it?
the fact that there is a crash is actually also, we could say, a good thing, because if there was not, basically, like we could corrupt our data,
Yeah,
put the app in an
yeah, we are in a
undefined state. I
very
mean, anything goes.
exactly. We're in a very inconsistent state that we do not want to be in. So this is also protecting our application and making sure that everything's fine. So one way to get around this that I typically use is to say, okay, I'm going to make sure that only one thing at a time is going to access stuff. So I'm going to create a private dispatch queue for that. Dispatch queue label, that will be, I usually just make that a UUID string because it has to be unique, and
Yeah.
I don't really care what it is. So every instance of lookup thing is going to have its own queue. And then I'll say that every time I want to write to this queue, that has to be done safely. So I'm going to queue.async, and then I'm going to look really cool and use a feature that I don't often use. And that is async, and then we should have a barrier option, right? I'm not going to see it immediately. Then I'm going to, there we go. We should be able to do something like that. And if I'm not mistaken, Vincent, I believe you are maybe more of a concurrency guru than I am, but this should make it so that we safely write to this dictionary, does it not?
Yeah, because the idea is here, like we use the queue as a synchronization mechanism, basically.
Exactly. And then this barrier should make it so that only one write can happen at the same time. So now I believe if we run the app, we should already be fine. And before I explain why I want to see this work,
Because you never know
there
when
we
you do
go.
these kind of things, if it's going to work or not.
Exactly. Okay, so it works. And as you can see, what's interesting here is that we first print an empty dictionary a bunch of times. So that's maybe a little bit weird. Then we do have a bunch of values in there, but eventually we should have a dictionary with all the values. And what we could do is actually, once we have performed all of our work, we could check what's in the dictionary. So we can use a dispatch group to run something when all 20 of these concurrent iterations have finished. So say group dot notify global that. Now say group dot enter and group dot leave. Now I believe this is going to give us this is going to give us a crash because I have no idea what I'm doing right now. Let's see. This is a data race. I know that for a fact. Just
Maybe.
do. You could actually do this. Q. We're going to synchronize all the things. Q.sync. Could also be actually that I need to do that. But the order of the notify is important, isn't it?
Yeah, I was
There we go.
thinking there was you're not saying like I wanted to be over after like 20 instance of leave, so I guess
Yeah.
it does. Okay, so
So
we have
there
the
we go.
data.
So this is our dictionary, and it should have 20 values. Let's see. Lookup.getAll.keys.count. So it should have 20 of those. Cannot find print. No. Not going to glue anything. We're going to print.
So let's see.
There
Yep.
we go. 20. Perfect. Okay, so this is the pre-async way of solving that problem, right? We had a problem where we would concurrently modify a dictionary, and that's going to give us all kinds of crashes and issues and whatnot. So then we're going to synchronize access by using a dispatch queue and making sure that this dispatch queue is going to make sure that only one thing is writing at the same time. But as you can imagine, just because even though I've done this a whole bunch of times, I keep forgetting all these things, and it's very easy to forget to do this or to get this wrong, or to make mistakes with this. And it's a lot of extra code that you don't really want.
Exactly, and it reminds us of when we had to explicitly manage the memory, so explicit retain and release. It's kind of the same
Right.
thing, but applied to synchronization.
Pretty much, yeah. And there's also other ways to do this, right? We can use logs, or we can use mutexes, or whatever, or semaphores, I believe, or another tool to solve this same problem. But they all have similar issues in that you have to remember to use them. You have to make sure that you use them correctly. You have to make sure
Yeah,
that you don't deadlock. You have to, because these functions are simple. I have written code where you have this whole RX Swift or combined pipeline, where somewhere in the middle you have to work with the dictionary. Now, good luck remembering that you have to do this, right? You cannot do this automatically. You have to use the correct method of interacting with this. So that's not great. And with Swift concurrency, the Swift team was like, this is not how we want to write Swift, right? Swift code has some characteristics like it's hard to get wrong, it's safe by default, right? It should be somewhat intuitive, it should be easy to write the correct code. So what they introduced is the concept of actors. Before I get into actors, what I want to do is I want to refactor our little bit of code a little bit to use Swift concurrency, so that we can then see the problem again and solve it in Swift concurrency. I'm going to get rid of these print things. I'm just going to make sure. You're just going to have to trust me that it works from here on out for a little while.
We are
So
trusting
we're
you.
going to say async, and then we're going to do this. And we're going to run this code. It's only available on iOS 15 or newer because clearly I figured I would want to run this on iOS 14. Don't ask me why.
So let's
Okay, here we
see
go.
what's happening.
So run the code, nothing is printed. That's exactly what I wanted because I don't have any prints anymore. I just didn't want this to crash. If you want to see, we can put a breakpoint here
and see
and
what's
see that
happening.
see breakpoint is triggered.
We can see the index being
Yeah,
updated.
and this is going to happen 20 times. I'm not going to hit the breakpoint 20 times. So okay, that's good. That works. That's fine. But let's get rid of the queue now because we're going to just use Swift concurrency and write the code that we wish we could write. So we're back basically to square one with this class.
Yep.
And I'm going to run the code and nothing happens. Now, Vincent, tell me, why do I not have a crash here?
That's a good question.
I know.
Why could it be so? You've added async, so now um, it could be that actually async dispatches everything to the same queue under the hood. That could be one of the reasons. We could see it just by putting a breakpoint and taking a look where did the execution stopped.
Let's do it. So we can see we're on thread 5 here for this one. Still on thread 5. Thread 5. So we're going to stay on this queue the whole time. And the reason for this is structured concurrency, because this task that we have here is going to be spawned as a child task of whatever task we're on right now, and tasks inherit their actors. And this actually already makes it really hard for us to write the wrong code.
But on the
Interestingly.
other hand, the code is no longer parallel, so dispatch concurrent perform is just like it's behaving just like a for loop.
Right, yeah. In this case, it is because it's being dispatched onto the same queue the whole time. Now, I have not really found a way to force Swift concurrency to put this on different threads. What we actually could try, maybe, is
I
to
was
just
thinking
write it like this: for index
what about if
in
we had used async detached instead?
detached. That might actually. Is it async detached or just detached?
For now, it seems to be async detached, but I'm saying if you are watching this video sometimes in the future, and it could be like just the next beta, they are planning to rename async and async detached, I think, to task.init and task.detached.
These will be the two things, I
Yeah,
believe.
it was supposed to happen in the beta 2, it didn't, but every content is basically obsolete in a few weeks, I'm afraid.
Pretty much, yeah. Okay, so it seems like we still don't hit this problem. And this is a little bit annoying when you want to demo this stuff because you no longer have the control over threads that you used to have um, without Swift concurrency. However, believe me when I say that there are ways in which you could most likely get this to still misbehave. And I'm trying to think of a good way, but I thought about it a lot already and I really just come up blank every time. So what we'll just do is we'll just assume that this can crash. And maybe we can, if anybody watching has any idea of how to crash this, please throw it in the chat and I'll give it a go.
I was thinking you could still create a queue inside the async block and run the code on the queue explicitly. And it's like we are jumping back from one concurrency system to another.
Yeah, we could try to invert it. Why not? Open to anything. Hey, that was very smart, Vincent. You broke our code. All right, so this puts us back in this puts us in Swift concurrency territory, and it breaks the code. So that's great. So let's see what we can do to fix that. And Swift actors are a way to fix that. And actors are a lot like classes. They are reference types. They can conform to protocols. They just cannot inherit from other actors. They can inherit from NS object. That's the only thing I believe they are allowed to inherit from, because NS object has no state. It's just a bunch of methods. So it's not mutable, or there's no mutable state. So to make an actor, all we need to do is change class to actor. So now we have an actor lookup thing. And this makes it so that anybody who wants to either directly or indirectly read this property or mutate it has to be synchronized onto the actor's queue or the actor's message box, more or less, right? So we're going to put in requests with the actor to either mutate or read stuff, and the actor will serially work through its requests and do what we want. So if I compile the code right now, we should get a compiler error here. And it says actor isolated instance method can only be referenced from inside the actor. Now this is not entirely true, but it does tell us something. It's that we cannot just call set value just like that. Because when we call set value like this, what do you expect to happen, Vincent? How does that work?
Well, when you call the method on the actor, I mean, when you look at the call site, it feels like it's going to execute in the current thread, whatever it is.
Yeah, and then most importantly, when is it going to execute?
Uh, as soon like whenever the control of the program of the workflow reaches the line.
Exactly. So basically, right now, right? When I
Yeah,
call this, when this is executed, it has to be called right now. But as I just explained, the actor will have this message box and it will have to work through these things serially. So the actor might not have time to set value right now. It might have to set other values first, or it might have to do or fulfill a request to get all first. So that means that this is now an asynchronous method from the outside perspective. For the actor itself, it's still going to be synchronous, so we're not going to mark set value with async like you would in another asynchronous function. We're going to keep it like this, but we are going to have to await its outcome. So yeah, this is what I thought. Because we are sort of doing something weird here, we're being async and then we're going non-async. We're gonna have to go, I believe, async again
yeah,
inside of the concurrent perform. And this will make it so that we are now in the appropriate context to do this. We're actually going to get rid of this outer async. We don't need it anymore. Um, so what we're doing right now is we're saying concurrently perform this stuff, and then we're going to enter an asynchronous context. And that means that we are okay with waiting for things when our code looks
yeah,
serial, right? So this print will always run immediately. But that print will always be printed immediately.
and from
Then we'll
whatever
do
thread
this.
we are on also,
Sorry?
and also it will be printed like from whatever thread we are on currently.
Exactly, yeah. And then this await right here, that might take a while, right? In practice, we know set value has a very fast implementation, so we would have to rack up a lot of these concurrent set value calls. But generally speaking, it should be quick. And then after that's done, we would have another print, right? So after the set value. And so our async block, that closure here, could be paused right there.
Yeah,
And that's why we need to be in an async context so that Swift can create a task for us and that it can suspend the task and let something else run and do all that work. And this has to be marked with await because we might not be able to set value immediately. So let's run this code, see what happens. As you see, this all runs very nice and serially because of what we just explained.
yeah,
This async task is a child task of whatever we're currently in, so it's going to be in the same thread.
yeah.
So
And if
that is, in a nutshell, what we use actors for. Do we have any questions or anything from people watching to talk about? If not, I have more to tell, but this is a nice natural point to reflect a little bit on what we have so far.
We don't have questions right now, but I guess that yeah, now that we are mentioning that, of course you can ask questions and we'll try to answer them as best as possible. Maybe question will come to mind to people who are watching. There was just one question at some point, but it was actually answered in the chat. So Ahmed was asking, does async await replace GCD?
Yeah, and I see the answer actually, and the answer is no. Um, I do believe that async awaits, when people talk about it, they typically talk about Swift concurrency.
Yeah,
And yes, this new concurrency model of structured concurrency and tasks and all that stuff, that will replace GCD. Async await is really just this little piece of syntax right here, right? So async await isn't the whole suite of concurrency features that we got now.
exactly. And I feel the way that we can also see it is to say like once you have async await in your code and you can introduce concurrency so easily, well, you need to have other things to make sure that your code is not like going to go into all kind of issues. So it's kind of like structured concurrency. It makes async await kind of behave, or yeah, it structures it. Basically, the name makes sense.
Yeah,
Okay, so we have a
yeah,
question. So Shakti is asking, can we write async inside actor set value function?
we could. Yeah. So, well, what you shouldn't do, generally, it's probably not what you want, is write this. So we don't really want to open a new async scope inside of this actor. We could if we really wanted to, but there are generally better ways to do this, especially because actor already is an async Swift concurrency related sort of construct. So what you could do, I believe, is to just mark your function async,
And then
right?
we
So
could
we
use
can
await
do that.
inside.
Yeah, exactly. And now if you would say like, well, what I want to do here is I want to, I don't know, make some network call or whatever. You could await URL session dot shared dot what shall we do? Data task with URL string. And just because there's a nice little bit of friction there, let's await the HTTP body for practicalcombine.com. Why not? So, right, we could do this. This is fine. Uh, result equals try await because this can throw. And we could print the result first. And now, how about we do this? This is not a throwing function. I have a hard time believing this compiler error. Oh, wait, this just creates a task. Which is the async await version for this, Vincent? Do you know?
Oh, there were no, it's for delegate. So it's the one that returns a tuple, so you can look
Ah,
for
this one.
this.
Yeah, yeah, yeah. Download for then. Is it not?
Um,
Or your data for? Ah, okay, okay. Now we're
okay, there
throwing.
is no more. There is no task. Okay.
No exact matches. That's correct because the argument label is 4. Cannot convert value of URL to type URL request. Hold up, hold up. I do believe we had a version for URLs too, right? Data with. No. Data from. Okay.
So we have the URL. Yes.
Now we're good. So now we should get, you'll see that we have all this output here. And this output actually is, I'll go up a little bit. So the prints are actually quite nice right now. So you'll see that we get all of these will run immediately
Yeah,
print statements. And then we get the output of our HTTP request.
yeah,
And then we get after the set value. So you can see how all of these tasks are started at the same time.
yeah. And we can see that they are kind
And
of
this runs. And then our task is paused at the await because this set value function now really takes a long time because we're going to go to the network first.
yeah,
So it'll wait for that and then it'll resume and then we'll get after the set value. So that's why the output looks like this. And this
that's
also
nice.
shows you that even though that for loop looked like a normal for loop earlier, right, where it looked like it was all going to happen sequentially, you can now see that it's not actually sequential. It's actually using Swift's
Yeah.
async wait to pause this async block mid block and do something else. So that's pretty cool. So can you write async stuff in the set value? Yes, you can.
I was thinking, do you have to also mark the function async or not? I guess you still have it. Yeah, because you're an actor, you're not allowed. Yeah, you still need to say it's async even though you are within an actor.
Yes. So the trick here is that from the perspective of the actor, because the actor is the only one that has unlimited save access to the safe value
Yeah,
set value function, and to the actor, this set value function is in fact a synchronous normal
it makes
function.
sense.
It's just when you want to access it from the
Exactly. Yeah.
outside that it becomes async because it's isolated by the actor. So it's not the function here that's asynchronous. It's more like the actor is making it asynchronous to other people.
Yeah. So it makes total sense.
Yeah. So that is sort of how actors work essentially. Now, let's do something interesting. I'm trying to think of a good idea here because I want to show you global actors, or like the
Oh,
actor, like the main actor annotation.
so global actors, it could be things like. So I'm not sure if that kind of SDK makes sense with an actor, but things like an analytics that you would call from many places to say I want to record that event. But I'm thinking, would you want
Yeah, yeah,
to?
yeah.
You would have to use await every time that you are recording an event. So we can show the example. Actually, maybe like in real life, I'm not sure whether we would like to, but yeah, it would make sense. Yeah, I guess actually like most analytics library, they have some kind of barrier at the entry to make sure that no two screen are recording an event at the same time. So
Yeah, exactly. Yeah. So because I would have to go into the compiler settings and do all kinds of stuff that I didn't prepare beforehand, I'm not going to do that specifically, but I'm going to show you a main actor that I did actually prepare a little bit. So what we can do is we could have our Swift UI view here, and we could have a class, and that class could be a data source, right? And the data source might be an observable object, and it might have a published property of name, and that's going to be a string. We'll have a function get name, and that will just set the name to hello world. This is pretty standard Swift UI stuff, and we might have a state object var source, and it's going to be a data source here. And then to run the code button, it's going to say source.getName. And above this, we'll make a vstack. And we'll have a little text, and the text is just going to show us source.name. There we go. There's no initializer, so it's going to do that. Actually, I don't like this example at all. The name is going to be some random string here.
that changes every time.
Exactly, because otherwise it's going to be hard to see what we're doing.
Yeah.
So this is all fine. And then we could do something like dispatch queue dot global dot async. I have to do a little bit of self capturing here. Do we need weak self here or not, Vincent? What do you think? Just to get a little bit of your
Um,
opinion.
I would say you don't because the global queue is not going to retain the closure after it has executed. So I would say you don't.
Exactly. Agreed. That's my opinion too. So this will run fast. This will run soon. It will run once. So it's going to be discarded after. And now I have this beautiful purple warning here that says publishing changes from background threads is not allowed. Make sure to publish values from the main thread via operators like receive on model updates. So this is basically telling me you're doing it wrong. You're manipulating data that's driving your UI from a background thread. UI updates and the updates for the data that's driving your UI have to be on the main thread. So normally, you might want to do something like not write this code, but let's assume that we don't control that, right? Let's assume that this comes from somewhere else.
Yeah,
And you know
the
what?
network call, anything.
Let's actually just write a name fetcher, and they'll have a fetch function. It'll return a string. Or actually, it's going to take a completion closure. We're going to go full on async with this one. I have a completion. It's not going to be escaping. It's going to call with a string. It's going to return void. Take this code, we'll put that there. And then we'll just say call the completion with a string. And then get name is just going to say, I'm going to use my, almost going to start to look like something you might have in a real project, isn't it?
Yeah, it's that pattern of
Right?
making some kind of call, getting the data asynchronously, and displaying it on the screen.
Yeah, of course, it's escaping. There we go. So what I wrote right now is a pattern that you probably have in your app where, the name fetcher pretends to be the
Yeah,
network and it'll do something asynchronously. It'll call a completion handler,
yeah.
and then once we fetched it, we would do this. So earlier I said you could just not do this. Now
But
that's not an
now,
option, right? Now we don't own the name fetcher. It's going to the network. We need to do something. So you would say, okay, I'm going to say dispatch queue dot main dot async.
so we are switching back explicitly on
Right.
the main queue.
Exactly. And then we're going to assign to our published property that's going to update the UI on the main queue, and the app will be very happy about that. Now, this is nice, but again, it's something we can forget, right? Imagine that you're
Yeah,
a couple levels deep into your code and you have all these things going on. This is going to be something that you won't think about, probably.
exactly. And even worse, like if you have several layers, it's very hard to know, like, did one of the layer, well, below me has already called the method. Sometimes like you end up calling it actually several times because all of the layers starting from a certain point want to be on the main thread. So you call, and it's actually not useful.
Exactly, yeah. And so the code you want to write is really this. You just want to assign self.name equals
Yeah,
fetch string. So one thing we can do is, and I have not tried this literal little experiment right here. So we're going to go ahead and run that, see what happens. And once it works or not, I'm going to explain what I did. Okay, so that doesn't work. That's fine. So adding this add MainActor annotation to my class will make it so that this class is now isolated to the main actor. So it's now as if I did this. But it's almost as if I made my data source an actor, but it's not. It's more like an object whose code has to run on the main actor. Right, so every time I change something on, or I assign anything to state of this data source, like updating the name, that will now happen on the main actor. So if we run this code, we do get warnings. Swift, I hate you.
it's I can tell you because I recorded a video on the topic 2 days ago. It's because
Is it a bug?
actors, no, it only works when you are on an async context. When you use a completion handler or anything else, it doesn't work, and Swift has no way to warn you. So it's the tricky part when you work
Oh gosh.
with this kind of global actors.
Oh gosh. I'm pretty sure actually that the Swift team or some WWDC video demoed this. Anyway, let's push this into async territory. Why the heck not? We can make this async. We can make this async, and it's going to return a little string, right? And here's something interesting. Now imagine that, well, actually, no, we're going to keep this in a very boring way. We're just going to make this not async. We're going to make it async, but it's not actually going to be async. Whenever you write asynchronous code, it doesn't have to be actually async, right? So this is just telling us this could be async, but maybe not.
Yeah.
So now we have that, and we'll have this. So you're saying, Vincent, that self.name can just be await
Yep.
fetcher dot fetch. And actually, we'll do
I
that.
Yeah, you can do it like this.
Because now I don't have to
Yeah, you
change my
can
switch.
call it like from
Exactly.
anywhere.
So now we are good. That is interesting that this only works if you are already in an async context.
It's very weird, especially like when you hear about MainActor and you try to look at UI kit code and you're like, why doesn't it work? And that's the yeah, deceitful part of it.
Yeah, and I mean, now that I think about it, it actually kind of makes sense because Swift concurrency is not intended to play well with GCD. And what I just tried to do was take my GCD code and force it into the rules of the Swift
Yeah.
concurrency world, which clearly, now that I think about it, I'm just going to blame it on COVID. Can I blame one thing today on COVID?
I think we can blame many things on COVID this time.
I, mean, I actually was tested positive yesterday,
Yeah.
so or
So
the day
yeah.
before yesterday. So okay. Anyway, enough about that. So that main actor makes it so that this data source now has to synchronize all of its asynchronous access onto the main actor queue, which means that we don't have to think about dispatching to main, because that's what this annotation does. And with the global actors that we just briefly mentioned, you can actually write your own actors that you can use as annotations. And then you can sort of group things onto your own actors, which could be useful, for example, for something like analytics, where you would say, like, I always want these sort of logging things to
Yeah.
happen on my queue or on my actor because I own this part of
So
global state.
it's kind of like when basically like it's the use case where you would have maybe several actors and you want them to always be executed on the same state. So it's basically kind of like if you want to synchronize several actors together. I don't know if you see it the same way.
Yeah, pretty much. Yeah, I would say yes. That sounds good. So I just looked at the chat real quick, and actually, what Prathamesh says is makes total sense. Kind of also what I just said, and which is that get name will be called on the main actor, but if we do dispatch queue stuff here, that will not be on the main actor because we are explicitly leaving
Yeah, that makes
that
sense.
switch concurrency world. So thanks for that sort of clarification, Pratt. And then we have the question, what is GCD? And that stands for Grand Central Dispatch. And it's what Apple released years ago
15
to
years
help
ago
us do
maybe. Yeah, something
concurrency.
like this.
So it's the precursor to Swift concurrency, actually. So
I think it comes back to all of the days of macOS Leopard. So it's
probably, yeah.
it's all. I think it was when Mac started to have CPUs with two cores, and so there was a need for an API to like do threading more easily than using pthreads. So at the time, GCD was super high level, and when you were seeing it after having learned about pthread, you were like, "Wow, this is amazing!" And then 15 years later, we have the next evolution.
Yeah. Yeah, I wonder what it's going to be like because I remember when GCD was supposed to solve a lot of threading problems, and we could safely create queues and queue everything and make as many queues as you want. And then a couple of years later, I was like, "Yeah, make as many queues as you want, but preferably like three or something."
Yeah,
So so what I did earlier in that sample runner where I had this queue that would synchronize things, that's really not what Apple wants you to do because these queues they all create their own threads and you get a ton of threads and switching threads is expensive for a CPU. And that's also why Swift concurrency is basically like, you know what, these threads are just implementation details. We're going to do tasks now. So these tasks are more lightweight than threads, and they're easier to toggle onto different threads. And threads should match. So the amount of threads that Swift concurrency will use should match your number of CPUs,
Yeah, that's
which
something
will still be
I've
a ton
read.
of threads because I don't know how many CPUs the M1 has, but it's more than four. It's like 16 or something, isn't it?
So I'm curious to see like when we start to see some real world benchmark when people start to maybe like share that yeah, when they use structured concurrency their code they can see that it goes much faster and without the need to introduce some complexity that sometimes it feels like if you put too much synchronization code you paint yourself into a corner because then maintaining this code becomes incredibly costly for onboarding people on the team. It's a nightmare. So
Yeah, for sure. It's not getting any easier once you start making it more complicated. It really gets complicated fast.
we have an interesting question. How does async await interoperate with NS operation?
Not.
Yeah, that's what
That's
also
short
my
answer.
thinking. Yeah, that NS operation seems to be a thing of the past for most cases.
Yeah, so I think if you want to sort of mimic things that NS operation does, so there's a few things that I can think of that NS operation could do. One is run like a group of things and wait for all of these things to be done, right? Something we could model with a dispatch group, but we can also use NS operation and an operation queue. For that, we now have task groups, right? So we could do
Yeah,
something like with task group.
I'm remembering the slide from WWDC. We have task group when the number of operation is dynamic, and when it's static, we have even better. We have async let, which is like NS operation, but with some level of black magic that makes it so
Exactly, yeah.
smooth. It's impressive.
Yeah, so that's what I was going to suggest next after like with task groups. So with task groups, you can create a bunch of tasks that all produce the same output. And you could either just have them all run, or you could first wait for all of those tasks to complete, and then sort of reduce all of these results into a single value or result or something that you want to use. So that's task groups, and that's for cases where you want to say like I want to do all these operations and wait for them to finish. If you have like three one-off tasks and they all three depend on each other, that's just three calls to await, right? So self.name and then maybe self.surname equals fetcher dot fetch surname for name, right? So these tasks are all done by the time the previous line executes. So that's sort of what operation would do
Yeah,
for these one things. Now, some things are still kind of missing. For example, progress events. Um, they don't really belong in the async await world like that. Um, However, I could, for example, see combine play a nice role in that, where you could have some object that's going to await some value and have a publisher to report progress. But
yeah, yeah,
right, so it doesn't necessarily. And of course, you could probably make your operation. You could actually surely make your NS operations behave well in an async await world. It's just
yeah.
they weren't designed to cooperate.
Exactly, and also the APIs from Apple they have shifted. So and there is also the part I think it's still not available in the beta, but it's async stream to create an async sequence.
Yeah,
So it's kind of like you can on one await it can generate several values, and so we could imagine, for instance, for progression. Something that returns an async sequence and it's an enum and it can be either a progress or a done or an error and actually maybe we will see this pattern coming up in APIs in the future,
yeah, for sure. Yeah, yeah. You could repeatedly call that continuation closure to communicate progress.
but it's still not available in the betas.
No, I
uh,
think beta 3 is going to be a huge one.
and I'm really looking forward to using async stream because it seems very powerful and once again between the world between just async await and combine, so super curious about this one. We have a question. So Shakti is asking, without as main actor, can we try that as the function is already marked as async?
Yep,
Uh,
I'm trying it now. So as you can see, the warning's back. So we run this asynchronously. We step out of the main thread. We publish changes, and the purple warning is back.
and did we cover async let? No, we didn't cover it. It's a topic of it's like as we were saying with Donny before we started, we could make like an entire summer of content. I'm sure just on the topic of structural concurrency because there is just so many things. So no, it was not part of the scope for this evening. I have
Yeah,
videos from January about it. For they are mostly still valid even though things have changed. But I have one video on the channel that you can. Find if you scroll down for some time.
yeah. So just to briefly, sort of, if anybody's like async let, what is it, and why are they not explaining it? I just mentioned the task groups, and Vincent actually mentioned async let in that context because that's where they belong. But we have task groups to say like I have a number of tasks that all produce the same output, or I have made them to produce the same output, and I want to run those tasks and have them all be associated to each other. And they'll run in parallel, so they won't be run sequentially. However, you could also say like I have these two tasks that can run in parallel, but they produce wildly different results. Like one could maybe fetch my user's profile, and the other one's going to fetch my user's favorite photos. These things could run concurrently just fine. You would probably just make an API call with the user ID to two endpoints, and you wouldn't really care like who finishes first because they don't depend on each other. And then you could use async let, and by the time you need either of those, you can await it, and at that point you will halt or suspend your task for a while until that value is available. But the task will run in parallel. So that's async let with the notation that I have here in the self name equals await fetch or fetch. That means that this next line, but we can actually demonstrate this. Why not?
Yeah, we can.
Or show what it looks like because this code is way too fast to demonstrate it with fully. But for example, we could do this.
I
And this means that we're first going to get this one, then we're going to get this one, and then we're going to get this one. But maybe I say, you know what, I want to do like these two can be done at the same time. So then I can say async let new name equals and async let new name 2 equals. And now these two tasks will run in parallel. And at some point, I might want to have their values. So I could say let 1 equals, or actually, I'm going to say print await new name and new name 2. But so I cannot do this. Let's start with that. I cannot do this because these are two asynchronous tasks. And that means that I kick off the asynchronous task immediately when I create this thing, but I'm not waiting for its result. So by the time this print hits, I might not have this result. There are a few things that I could do here. I could say await new name and await new name 2. But await follows conventions from try. So I can also say await print new name and new name 2. And this should be fine. And the reason is that this whole expression simply becomes awaitable in the suspension point. So it doesn't really matter if I put it here or in front of each of these two things. And that's also true for try. Like if this would be a trying operations, I could do try print, or I could do try new name, try new name too.
yeah, basically try and await. They work. I mean, from the syntax point of view, they are extremely similar.
Yeah, they follow a lot of the same conventions, which is really good. So what else do we have?
And what's really great is that basically, from like if we try to make the parallel with combine, it's like the zip operator, but without actually having to introduce an operator or anything like that. So anything else, it's extremely like seamless.
Yeah, yeah, they are a lot like zip or other similar combine operators that you could think of, for sure.
Looking at the chat, if there are not any more questions, I think we've covered like a lot of content. We've definitely covered the content we wanted to cover this evening, and I'm sure that even though it was a lot of things, when we look back in a few months, we'll be thinking like it's only the introduction to actors, because
Yes.
there are things like, for instance, if people want to go further, the keyword non-isolated, when you want to make a particular method exit the scope of the actor. When you have global actors, you can annotate either like the entire type, but also specific methods. So there is a lot of ways to do to use an actor.
Speaking of non-isolated, for example, I could do this. I would have to make these functions async, but because they don't mutate anything, I could say like, hey, you know what? These don't have to be on the actor. Or
That makes sense.
even if, let's say get all, or maybe this thing, let's keep these things isolated, but maybe this thing also has like some function that does something silly. I'll just, you know what? It's a thing doer, so I'll just make it random thing, and it'll return a UUID. And we can say return an instance of UUID. Right, so this function would now be actor isolated, even though it doesn't access any mutable state on our actor. So we could say, you know what, this function is perfectly fine to be non-isolated. This doesn't have to be run on this actor's isolation rules, because I know that it's not. There are no data races. It's physically impossible to have a data race here because it's a new instance of UID every time. So that's quickly the non-isolated thing. I think we're going to wrap it up. So I quickly want
Yeah,
to summarize like actors, because we sort of sidetracked into some SwiftUI stuff there. So actors help you make sure that if multiple tasks read or write, or read and write rather, the same piece of data, so in this case a dictionary, if we have multiple demands for reading and writing that dictionary, we could get a crash normally. Now, with an actor, we make sure that there's only one such access going on at the same time, because the actor will isolate all of its state and make sure that only one request, or one message, basically, because they call it a message box, what the actor has, one message at a time gets processed, which means that we cannot get data races. However, that makes it so that accessing things on an actor, accessing mutable states on an actor, is no longer synchronous. So we have to be in an async context, and we have to await the result, because the actor might be doing something else before it gives us the result we wanted. That's actors in a minute.
and yeah, I think it's a very good way to, well, to wrap it up and to end the live. So I've just put in the chat a link to your website. So for people who didn't already knew you, you have a lot of content. You have blog articles, you have a newsletter, you've published 2 books about Combine and Core Data.
Yep.
So if you didn't know about Donny's content, well, go check it out. It's high quality content with regular updates. So you will definitely like won't regret it. And well, I think I just have now to thank you, Donny, for coming here with me this evening and giving us all of this great introduction to actors.
Yeah, thanks for having me. It's been a pleasure being here.
And well, thank you everyone for watching, for asking great questions, because it's what makes a live so interactive and make a content that really matches with what the audience and what you are expecting. And that being said, well, thank you for watching, and see you next time for another live, another video. Bye bye.
Bye, everyone.